Alright, so the last thing we're going to talk about with this section is called the power of a test. So researchers often perform a significance test in hopes of finding convincing evidence for the alternative. But researchers would make a type 2 error if they failed to find the convincing evidence. So how likely is a significance test to avoid a type 2 error? Well, we refer to this probability as the power of the test. So the power of a test is the probability that the test will find convincing evidence for the alternative when a specific alternative value of the parameter is true. So here's looking back at the battery life of those AAA batteries, those deluxe AAA batteries. So again, remember they're originally 30. We're thinking that these are better batteries, so they're going to be greater than 30. So it says that the power of the test to detect that mu is 31 hours is 0.762. So what does that mean? If the true mean lifetime of the company's deluxe AAA batteries is 31 hours, there is a 0.762 probability that the company will find convincing evidence for the alternative. That means the probability that they will reject the null hypothesis. So what's the probability that the company makes a type 2 error? It's a conditional probability. It's about the probability that they'll reject. So the 0.762 is the probability that they'll reject the null hypothesis when and if they know that mu is 31. So the probability that they make a type 2 error would be that they failed to reject. So it would have been the complement. So the probability they failed to reject the null hypothesis when the true lifetime of the deluxe AAA batteries is actually 31 is 1 minus that value, so 0.238. So power and type 2 are complements of each other. So to calculate power, we do 1 minus the probability of a type 2 error. To do the probability of type 2 error, it's 1 minus the power. On the AP exam, you'll be asked possibly to calculate one or the other, but they're going to give you one, and you just need to find the complement. You're not going to actually have to calculate one of them to then find the other. So how can you increase the power of a significance test? Well, we can increase the sample size, we can increase the significance level, but also the null hypothesis and the alternative value of the parameter, if they are further apart, instead of 30 hours and 31 hours, if it's 30 hours and 36 hours, if the true average lifetime of the batteries is 36 hours apart from the 30, because there's such a large gap, then that would increase the power. It's more likely that we will do a significance test which rejects the null hypothesis because the true value is so much different than the claimed value. Okay, so here we have an Alzheimer's experiment. They want to test a drug. They claim that fewer than 10% of the patients who take its new drug for treating Alzheimer's disease will experience nausea. That is, they want to carry out a test of P is 0.10 and the alternative P is less than 0.10. P is a true proportion of patients, like the ones in the study, who would experience nausea when taking the new Alzheimer's drug. So earlier we mentioned the power of the test to detect P is 0.08 using a random sample of 300 patients and a significance level of alpha is 0.05 is 0.29. Determine whether each of the following changes would increase or decrease the power of the test. So if we used alpha is 0.01 instead of alpha is 0.05, if the true proportion P 0.06 instead of 0.08, and if our sample size was 200 instead of 300. Well, if we have alpha as 0.01 instead of 0.05, it decreased alpha, decreases significance level, so it decreases the power. If our true proportion is 0.06 instead of 0.08, that would increase because the claim was 0.10. Remember, the null hypothesis was P equals 0.10. Well, 0.06 is further away from 0.10 than 0.08 is, Therefore, it would increase the likelihood that we would actually reject the null hypothesis. If we use a smaller sample size of 200 instead of 300, that will actually decrease the power because a smaller sample size is going to give us less information about the true proportion. So just some things to be careful of. Statistical significance versus practical importance. Statistical significance is not the same thing as practical importance. To help evaluate practical importance, give a confidence interval for the parameter. Confidence intervals are not used as often as they should, whereas significance tests are perhaps overused. Remember, confidence intervals can give us that interval of plausible values, whereas significance test is just saying yes or no. Beware of multiple analysis. Searching data for patterns is certainly legitimate. Performing every conceivable significance test on a data set with many variables until you obtain a statistically significant result is not. This unfortunate practice is known by many names, including data dredging and p-hacking.